All right, let's jump right in. Today, we're tackling a huge topic, one that touches pretty much everything in our modern lives: security in the Internet of Things. We're going to break down how we can possibly secure a world that is becoming more connected by the second.
And, that's not really an exaggeration. Think about it. From our smart homes and cities to the health trackers on our wrists, the Internet of Things, or IoT, is literally everywhere. These gadgets are constantly collecting, storing, and sending data to make our lives easier. But all that chatter creates a massive, massive challenge. How on earth do we keep it all safe?
And the stakes here are incredibly high. We're not just talking about data sitting on some server somewhere. When a smart lock on your front door or a critical medical device in a hospital gets compromised, the consequences are immediate and very, very real. These amazing devices can flip from being helpful assets to genuine dangers in the blink of an eye.
So first things first, let's step into what I call the IoT danger zone, so we can really get a handle on the threats we're up against. Okay, before we dive into all the ways things can be attacked, we have to know what we're trying to protect in the first place. You can think of security as being built on 7 core pillars. Confidentiality keeps your secrets secret. Integrity makes your data isn't messed with. Authentication proves you are who you say you are. Non-reputation is the proof that you actually did something. Availability means you can get to your stuff when you need it. Resilience is about how well a system can take a punch and keep going. And finally, safety ensures the device won't physically hurt someone. Every security measure we talk about is trying to uphold one or more of these pillars. Now, let's get some key terms straight. First up is a threat. Now, using the classic example, a threat isn't the actual burglar standing at your door. It's the possibility that a burglary could even happen. It's the potential for something bad to occur. Okay, so if the threat is the possibility of a burglar, then the vulnerability is the window you accidentally left open. It's the weakness, the flaw, the unlocked door that gives the threat an opening to become a reality. And that, of course, brings us to risk. Risk is where it all comes together. It's the actual probability that the threat, our burglar, will use the vulnerability, that open window, to do some damage. It's the measurable chance of the bad thing actually happening.
So you can see it's kind of like a simple math problem. A motivated attacker plus a system weakness is what creates risk. See, you can have a threat, but if there's no vulnerability, the risk is pretty low. And you can have a vulnerability, but if no one's around to exploit it, you're still basically okay. Real risk only exists where those two things overlap. So when an attacker decides to make a move, what does that actually look like? Well, generally, attacks fall into 2 main buckets. A passive attack is like someone just eavesdropping on your phone call. They're just listening, gathering info. An active attack, on the other hand, is when they jump right into the conversation, changing what you're saying, pretending to be you, or just hanging up the phone for you. Now, IoT devices, they have their own unique set of problems. Why? Because they're often small, they don't have a lot of power, and, you can physically touch them. This makes them wide open to very specific attacks, like messing with the low-power communication protocols they use, things like Zigbee, or even just plugging something directly into a hardware port on the device itself. Let's look at a chilling, real-world example. With the famous Jeep hack, security researchers found some major vulnerabilities. For one, the car's fun entertainment system wasn't walled off from its critical driving controls. This vulnerability allowed a threat to become a reality, with hackers sending commands to remotely control the steering and brakes, literally turning a moving car into a puppet. This is the definition of digital risk having very, very physical consequences. Okay, enough of the scary stuff. So how do we fight back? Well, the answer isn't just to run around plugging holes after they're discovered. No, the modern approach is to build a digital fortress right from the very beginning. It's all about security by design. This right here is the golden rule. You wouldn't build a whole house and then try to figure out where the locks should go, right? Of course not. You build the locks right into the blueprints. Security is exactly the same. It absolutely has to be a core part of the design process from day one, not some feature you try to tack on at the end.
But how do you actually do that when development is moving at lightning speed? Well, one popular way is to break security down into smaller, manageable pieces. You have your one-time tasks you do at the very beginning, like setting up coding rules. Then you have every sprint tasks that just become part of the routine, like having a teammate review your code. And finally, you have bigger bucket tasks, like hiring professional hackers to test your system, that you schedule every so often. This makes security a constant habit, not a last-minute panic.
A really powerful way to make this happen is to translate security needs into the language developers already speak, user stories. So instead of a vague goal like make it secure, you create a specific, testable task. This turns security into just another feature that can be planned, built, and checked off the list like everything else.
A massive part of security by design is just asking the right questions early. The first big one is all about privacy. A privacy impact assessment, or PIA, basically forces the team to stop and think, what personal data are we actually collecting? Why do we need it? And have we done enough to protect it? The second question is what makes IoT security so unique and so critical? A safety impact assessment, or SIA, looks beyond the data and into the physical world. It asks, how could this device, whether it's a smart oven, a factory robot, or a car, actually hurt someone if it breaks or gets hacked? This forces designers to think about fail-safes right from the start. So building a secure product is a huge accomplishment, but it's really just the beginning. Security isn't something you do once. It's a continuous process that has to last for the entire life of the device, from the moment it's first powered on to the day it's thrown out. You have to think about this lifecycle as a continuous loop. It all starts with implementing and integrating the device securely. Then it moves into the long phase of operating and maintaining it, and it finally ends with getting rid of it properly. And all the while, what you learn feeds back into the beginning to make the next product even better. So in phase 1, implement and integrate, the device finally gets out into the real world. This is where the rubber meets the road. It involves absolutely critical steps like secure configuration, especially changing default passwords. You would be shocked how often that's the main vulnerability. It also involves testing to find weaknesses before a real attacker does. Phase 2 is the marathon, not the sprint. This is the longest and, you could argue, the most important phase. The device is now out in the wild. This demands constant vigilance. You have to be monitoring for any weird behavior. You need a plan for when things inevitably go wrong, and, this is a big one, you need a secure way to push out updates and patches to fix problems that are discovered down the line. And finally, the end of the road. You can't just toss an old IoT device in the bin. Secure disposal is absolutely vital. This means completely wiping all sensitive data, a process often called zeroization, and revoking its digital identity so it can't be brought back from the dead to haunt your network later.
Which really brings us to our final thought here. These IoT devices, they offer us incredible convenience, but they also demand a tremendous amount of trust from us. And as we've seen today, that trust is completely dependent on a commitment to security at every single stage of the game. So the question I'll leave you with is, are we being careful enough about where we place that trust?